So getting into part 2 of lesson 4.5, we are now solving equations using inverse functions. In part 1, we graphed inverse functions, and so now we're going to solve some equations. So we're going to start out nice and basic here. So if we were to ask, what is the sine of pi over 6? So remember what that question is asking. Whenever you have a basic trig function, sine, cosine, tangent, the item that goes here is an angle, right? The item that goes here is a length. So when we say what is the sine of pi over 6, and we can do this in a calculator, and I'll do it here in just a second. But if we just said what is the sine of pi over 6, so we would travel pi over 6 radians, right? I'm traveling from here to here. And what they're asking for is what is the length of this distance right here, right? Remember, sine is a y-coordinate, right? So whenever they ask for a sine value, they're asking you how far lengthwise did you travel from here to here. Well, we went up a half a unit, right? And so that's why when we say what is the sine of pi over 6, what is the sine of this angle, the sine is the y-coordinate, it's how far we traveled up, and we would say we traveled up a half a unit. And so we get something like this, right? Just like when you say, what is the cosine of pi over 6? Right? So here's the angle that we traveled. The cosine is your x-coordinate. That one is asking how far did you go this way, right? And so we traveled from left to right. We traveled this far, right? If you turn that into a decimal, right? That's how far we traveled from left to right. This is how far you traveled from bottom to top, right? And so that's where those numbers come from, as we've already seen in the past. So if we throw that into a calculator, if you just type in sine of pi over 6, as long as you're in radians, we're going to come out with 0.5. So what if, and here's where the inverse stuff comes in, well, what if we are asked to solve the sine of what angle has a length of 0.5, right? So now they're changing the question, and they're now asking you for the angle, and they are giving you the length. Right, so here's where the inverse comes in, is how would we get x by itself? Well, how do we get rid of sine? We would do the inverse sine. And so essentially what we're doing is this right here. We are taking the inverse sine of both sides of that equation, because on the left side, inverse sine of sine would cancel each other out, and I'm left with just an x right there, right? So it's like saying x equals the inverse sine of 0.5. So this is now the equation that we're solving in our calculator. Okay, and so we could go into our calculator. We can do the inverse sine of 0.5. Let's do that real quick. Notice I'm in radians. So I'm going to do the inverse sine of 0.5. And now I get the angle. Of course, they're going to give it to me in terms of a decimal, right? It's not going to say pi over 6. Even though that is pi over 6, right? They're just giving it to me in terms of a decimal instead of in terms of pi. So we're gonna. That's typically why we also use like the unit circle and know those angles rather than get the calculator, because this one is we'd have to round it. This is going to be exact, right? And so that's why typically we would say pi over 6 rather than like 0.524, something like that. Anyway, so when we're asked to solve equations like this, recognize that we are now trying to find the angle. Okay, so and if you're in radians, you're going to get the angle in radians. If you were in degrees, you're going to get the degrees, right? So if I was in degree mode, instead of pi over 6, I would be getting 30 degrees, right? I'm going to get this instead of this if my calculator's in degrees. Just a quick notation issue. This is the same as this. So when we say what is the inverse sine of 0.5, that is the same thing as saying what is the arc sine of 0.5. So same thing. Both are asking for an angle. So whenever you see the inverse function, that means they're saying what angle has a sine value of 0.5 lengths, 0.5 units, right? Okay, so here's the issue that we have to take into account. This is what I'm leading into here. If you look at your unit circle, as we've already noted, this point right here, this angle, has a sine value of 1/2. Is that the only one? What if we go over to this angle? Doesn't 5 pi over 6 also have a sine value of 1/2? So how come my calculator is only giving me this angle and it's not giving me this answer as well? Right? So what we're going to see is there can be many, 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 many answers, but your calculator is only going to give you a selected answer. Right? And so here's what we're going to find on this. Let me go back to this guy. When you do a sine value, and this is going to be true of our sine values as well as our tangent values, but when you do a sine value in the calculator, here's what it will give you. If it is positive, it will give you this angle right here. Right? It's going to give you a quadrant 1 angle. If it is negative, it's going to go this direction, and it's going to give you the negative answer going from 0, traveling clockwise. And here's why it does that. If you look at the sine graph that we've been working on lately, right? When we do an inverse function, and I'll give you the quick history on this because we've done this before, but you've seen this, but it's been a really long time. When you want to find out if something's a function, right, a 1-to-1 function, remember the old vertical line test? So we could see that this is a function. It passes the vertical line test. But another thing that you would have seen probably in Algebra 2 is the inverse a function? So how do we know if an inverse is a function? Well, just like the vertical line test tells us if the original is a function, the horizontal line test tells us if the inverse is a function, right? And so you can see that the horizontal line test would say that the inverse function would fail, because now I'm going to hit the graph twice if I go horizontally. So how can I make it so that this graph where the inverse is a function? Well, if we limit the graph only from here to here, then it would be a function, right? If I cut off the rest of the graph. Because if I limit it from this point to this point, well, now it would pass the vertical line test and the horizontal line test. So now the inverse would be a function. So the way your calculator sees this is right here, right? So it sees only this much of the graph from negative pi over 2 to positive pi over 2, which is this information right here. So from negative pi over 2 to positive pi over 2 is what your calculator gives you an answer for, because only in that area of the graph do we have a 1-to-1 function where it passes the vertical and the horizontal line test. So when you do this kind of stuff in the calculator, it's going to give you an answer within this area right here, right? And notice it's not going all the way around to give you the quadrant 4 answer, right? It's traveling from here this direction and from here this direction, because this is all that it sees, right? It goes from negative pi over 2 to positive pi over 2 when it gives you that answer. So what we need to take away from this is there can be more than one answer. So we need to interpret what our calculator is giving us and then find remaining values if there's more, right? So when we type in something like, what is the sine of 0.5? Well, my calculator is going to say pi over 6 or 30 degrees. We need to understand there can be more answers to that, right? So when I look at my unit circle, like we already talked about, my calculator is going to give me this one, but I need to recognize this one is an answer too, right? So I have to kind of use this as my reference angle of 30 degrees or pi over 6 and say, where else do I have a reference angle of 30 degrees or pi over 6? Well, that would be this guy right here, right? This is a reference angle of 30 degrees or pi over 6. So just like I traveled up a half unit to get this angle, I can also travel up a half a unit to get this angle. And we see the mirror on the other side, right? These guys mirror over that y-axis. So my answer of 5 pi over 6, or 150 degrees, depending on what you're asked for, would also be an answer. So when we look at these guys, we're going to recognize that I not only got the answer of pi over 6, but I'm also taking into account the answer of 5 pi over 6. Something to keep in mind on this that will help you determine where all of your answers are. We talked about the All Students Take Calculus acronym. It tells you where certain functions are positive. They're all positive right here. My sines are positive here. Tangents are positive. Cosines are positive. So when I'm looking at this and I'm seeing in my calculator that I'm getting a positive sine value, 0.5 is a positive sine value, well, where else would I find a positive sine value? So not only in quadrant 1, but I should also be looking at quadrant 2, because according to this, I know my sines are positive in quadrant 2. So that's where I'm looking for my other answer. One thing that we'll talk about is if they just said, and remember, this is only one circle. Circles go on forever and ever and ever. And so one of the things we'll talk about down the road is how do I identify the fact that this is an infinite solution set? Well, we're going to say it's pi over 6 plus, and here's where I'm just giving you a little heads up on future notation. They're going to say 2 pi k, or 2k pi, where k is just how many times you're going around the circle, right? It could be infinite. It could be once around the circle, twice around the circle. We're just showing that this answer repeats every time I take another lap around the circle. And we would do the same thing for this one. I could say 5 pi over 6 plus, and I think they put the k in front, so they're going to say 2k pi. I forget if it's 2 pi k or 2k pi. Either way, k represents how many times you're going around the circle, right? So I can go once around, twice around, 3 times around. It's infinite. Okay, and so it's just a way of identifying that these answers carry on for however many circles you choose to go. What we're going to see mostly today, though, is they're going to limit your solution set. So instead of saying that it goes on forever and ever and ever, they're going to give you stuff like this, noting that they only want you to find the solutions from 0 to 2 pi, so only once around the circle. So instead of worrying about the whole 2k pi thing, saying that it goes on forever, if we get a limited domain like this, then that's telling us we're only going to give the answers from here to here within 1 unit circle. So what if we said the cosine of what angle has a value of 0.8? So the cosine of what angle has a value of 0.8? So if I did the inverse cosine of 0.8, I'm going to get this. Right? So 0.64, let's just call it 0.64. And we're in radians right now. A lot of times this makes a lot more sense to me if we're in degrees, to be honest, but so often you're being asked in the book for radians, so I try to show you as much work in radians as I can. Typically it tends to make more sense, I think, if we're in degrees, because we're so much more familiar with that notation. But anyway, so if we say the angle of, or what angle has a cosine value of 0.8, so if we traveled 0.64, so here's why I think the degrees and the radians are kind of tough to work with. Where would you find that on the unit circle? Like, how far are we traveling from, remember this is an angle, so I'm going from here and I'm traveling 0.64 radians. Well, how do I know where that is, or how do I know where to stop? Well, on this one, this is where you would have to understand in terms of radians. Remember, this is pi over 2. Right? Just like this is pi. You guys all know pi, 3.14, right? So in terms of radians, if I'm traveling from here, this is where I've traveled 3.14 radians. Well, how far if we only go to pi over 2? So if I just did pi over 2, then 1.57 is this guy. Right? So when I go from here to here in radians, I've traveled 1.57. So if I'm traveling 0.64, then I'm going from here to about, we're estimating, to about here. Would be an angle of, let me delete that, would be an angle of 0.64 radians. Right, that's our angle. So, and again, if you did in degrees, let me just do it real quick. Watch. If we did this in degrees, So if I did the inverse cosine of 0.8, so it's about 37 degrees, right? And typically if you said 37 degrees, you'd be like, okay, yeah, that's about right there, right? And so typically it makes more sense in degrees, but knowing these numbers will help you place which quadrant it's in. Okay, so keep that in mind. Anyway, so I need both solutions. Remember, my calculator only gives me a limited solution set. So here's something that's a little tricky. Just like the sign in your calculator only goes from, it goes from here, it goes from negative pi over 2 to positive pi over 2. So in the sine functions, your calculator sees this area right here. Cosine functions, for the same reason, see this area. So if it's positive, they're going to give you a quadrant 2 answer. Or sorry, if it's positive, they give you a quadrant 1 answer. And if it's negative, they're going to give you the quadrant 2 answer. Here's one way to look at it, and this is how I remember it personally. Sines are your y values. They go up and down. So if it's positive, I go up, and if it's negative, I go down. That's it. That's what we're seeing in the calculator. That's why sines go up and down, right? So if it's positive, you're going up, and if it's negative, you're going down. Well, what does cosine do? Cosine is your x's. So if it's positive, it goes to the right, and if it's negative, it goes to the left, right? And so that's why your calculator sees this area when doing cosine functions. So it goes from 0 to pi, right? So from here to here. So when I put this into my calculator and I got 0.64, well, where else would I find a positive, this is positive, 0.8, where else would I find a positive cosine value? Remember, cosines travel left and right. So whenever I go to the right, I'm getting a positive cosine value. So if I go to the right, I can go up and get this one, or I can go down. Either way, they're both positive cosine values because I went to the right to get there. So on this one, if that is one of my answers, then this one of negative 0.64 would be my other answer, right? But of course, we're not going to say negative 0.64 because that's not within our domain. I need to keep it positive. I need it to go from between 0 and 2 pi. So how do we get this angle? That's just a reference angle, right? What's the true angle if you were to start here and go all the way around to there, right? What angle are we really talking about? Well, we know the full lap is 2 pi. So if I can take this out of the way, whatever's left would tell me the angle from here to there. So if I did 2 pi minus 0.64, then that's really the angle that I want, 5.64. Radians. So again, the two answers that we came up with were 0.64 was the one our calculator gave us. This is the one that we had to get from the rest of the circle. So those are the two solutions within this domain. I'm not saying plus 2k pi because this doesn't go on forever. They've limited my domain to one circle. And so those are the two answers that we would get from that circle. All right. I just came up with a list of extra equations I wanted to go through with you guys just to help you for practice. So what if we say the secant of what angle is 2? So if we're going to say the secant of what angle has a value of 2, well, remember, try that again. So what angle has a secant value of 2? Well, that's the same thing as saying what angle has a cosine value of 1/2, right? And so we definitely want to think in terms of the three basic functions. So we're going to flip that around and say the cosine of what angle has a value of 1/2, right? We're going to do the inverse, and we want to work with cosine, not secant. So with the unit circle, super easy. So if we know this unit circle, when we get values like this, right, we can easily do this without a calculator. So for the problems that you're asked to do without a calculator, it's going to be numbers like this, right? Numbers that are within the basic unit circle values. The one that I just did a minute ago with the 0.8, well, 0.8's not, 4/5? 4/5 would not be on the unit circle. None of these are 4/5, right? So I couldn't do the last problem without a calculator. So if they ask you to do a problem without a calculator, it's because they're giving you numbers like this, or like this, or like this, that you can do from the basic unit circle without a calculator. So the cosine of what angle has a value of 1/2? Well, again, if we know these values, I can do this without a calculator. I can see my cosine of pi thirds would have that one. So how do we know if I should do my answer in radians or degrees? Because I could give the answer of pi thirds, or I could give the answer of 60 degrees. How do we know which one to give? Well, they'll typically tell you right here. So in this problem, they gave us a domain in terms of pi. Our domain is in terms of radians, which means I should be giving my answer in terms of radians, right? So if they give you a domain in degrees, so if this said from, what would that be, 90 degrees to 180 degrees, then I would give my answer in degrees. But because my domain is in terms of pi and radians, then I'll give my answer in terms of radians. So here's what we're going to notice on this one. So does this one exist in quadrant 2, right? This is pointing towards quadrant 2. So is it possible to have a positive cosine value in quadrant 2? Would that even exist? Let's look at our unit circle for a minute, right? Remember, your cosine values go left and right. They're your x's. So if I go to the right, I'm looking at these guys for positive cosine values. If I go to the left, these guys are my negative cosine values. So the one they're giving us right now wouldn't even exist. So we're going to change the domain on this so we can actually have a solution. The one that was given to us right here, we would have to say does not exist, or there is no solution. So what if I changed it to 3 pi over 2 to 2 pi? All right, so now if I change it to this, now where can I find my positive 1/2 cosine value? So remember, cosines go left and right, so if I'm going to the right, I can either go this way to get it, right here, or right there would be my other one, right? So 5 pi over 3 would be our solution if they give us the domain from 3 pi over 2 to 2 pi, then we can give the answer of 5 pi over 3. Let's try another. What about cotangent? So let's look at our tangent values. So the same thing we talked about up here, right? If they say cotangent, that's the same thing as saying the tangent of what angle is negative 1 over rad 3. Right? So if I do the reciprocal function, right, now I'm getting the tangent. And so we could see it this way. We could rationalize the denominator, write it as negative rad 3 over 3. But I think we're going to get it easier by looking at this. So let's take a look. So first of all, what are they asking for? What quadrant are you in if you're going from 3 pi over 2 to 2 pi? As we just saw in the last one, that is quadrant 4. So what they're asking for is what angle in quadrant 4 would give you a tangent value of negative 1 over rad 3. So we're going to look at quadrant 4, see which angle we can come up with to get that solution. I don't know why it keeps going back to that. Anyway, so as I look at this, so I'm looking at quadrant 4 right here. How do we get tangent? We do sine over cosine, or y over x. So I have to figure out, so in which one of these could I do a y divided by an x and get negative 1 over rad 3? Well, if you look at this angle right here, so if you did negative 1/2 divided by rad 3 over 2, right, the 2's would cancel, and it's going to simplify to be negative 1 over rad 3. And so we know for this answer, I'm looking at the angle of 11 pi over 6. That would be our angle. So pay close attention to the domain. If they give you a selected limited domain like this, we got to make sure that we're sticking to that and only giving solutions within that domain. For ones like this, what if they give me a number like 1.3? Right? That is not on the unit circle. Right? I'm not going to see that within any of my x's or y's on the unit circle. So this is where we would now have to use a calculator. I did not intentionally mean to give you all quadrant 4 stuff here, but that's kind of the way it worked out. But that's okay. So what if we said the secant of what angle is 1.3? Remember, that's like saying the cosine of what angle is 1 over 1.3. And so we're going to do the inverse cosine of this value in order to get the calculator answer for this. So I'm going to do inverse cosine of 1 over 1.3. And so I am looking at, I'm still in degrees. I mean, I wish we could do it all in degrees because I think that makes more sense, but in reality, you're going to be asked for a lot of radians, so I'm trying to give you exposure to that. Let's do the same thing in radians. So 0.69 radians. So guys, one thing that really helps on these, if you have to do this without a calculator and without looking at your unit circle, I always sketch these. So I would say, remember for cosine, if it's positive, they're going to give you the quadrant 1 answer. And if it's negative, it's going to give you the quadrant 2 answer. So right now, they're giving me the quadrant 1 answer of 0.69. So here's my angle. So where else would we find a positive cosine value? So remember, cosine values are positive here and here. That's where we find our positive cosine values. So I need the same angle, the same reference angle in quadrant 4, which would be 0.69 radians here. That's my reference angle. And you could put the negative to show that you traveled that direction. But the important part is they don't want this in terms of 0 to negative pi over 2. They don't want you traveling this direction and saying that it's negative 0.69. That's not within this domain, right? I need to give an answer that's between this number and this number. So instead of going that way, I need to be able to go like this and figure out how far I just traveled by doing that. So remember, this is 2 pi would be the whole circle. If I take this out of the way, I should be left with that amount right there. So if I did 2 pi minus 0.69, then I have my angle. So 5.59 radians would be my answer. That's a number between 3 pi over 2 and 2 pi. Right? So that would be our only solution for this one. Let's try one more. So we're looking at the cosecant, which again means I want to change that to a sine function. So we're going to say the sine of what angle? And 1 over negative 1.7. And I do this in my calculator. So this one says I can give any answer from 0 to 2 pi. So I get the full unit circle now. So here's a case where I can get more than one solution because my domain is big enough to accept 2 solutions. So let's just get the number first. So I'm going to do an inverse sine of negative 1 over 1.7. So I am at negative 0.63 radians. So let's see what that means. So if I travel negative 0.63 radians, so I'm now going this direction. So if I went negative 0.63 radians, first things first, can we even keep this one as an answer? Oops, sorry. I realized I was off the screen. So could we even keep that as an answer, negative 0.63? We can't, right? Because they want positives. They want me to go from 0 to positive 2 pi. So this is going from the unit circle starting from here and ending here. So I can't give a negative answer because I need from 0, something, a number between 0 and 6.28, whatever this would be, right? So if we kind of saw this in terms of decimals, I need a number between, I think it's 6.28, 3.14 times 2, sounds good to me. So I need a number between here to here. That's not a number in that domain. So, a couple things. Where do we find, in what angles would we find negative sign values? So remember, signs go up and down. So when I go like this, I have positive sign values. So these are my two quadrants for positive sign values. If I go like this, downward, I get negative sign values. So in quadrants 3 and 4 is where I should find my negative sign values. So I'm looking at these two quadrants. So I already know that this is one of them, but I can't go this way to get it, right? I need to be able to go this way to get it. So we're going to use the same trick that we used earlier. And I'm going to do 2 pi minus, or you know what I could actually do on that? Is I could just take that answer. I didn't mean to delete it. So I'm just going to take that answer. I'm going to add 2 pi to it. Oops. So 5.65 radians is going to be one of our answers, because that fits this description, and it's also a number between 0 and 6.28, or 0 and 2 pi. Right? So I know that's one of my solutions. Where would we find the other one? So, just like we were talking about, I know it should be in quadrant 3 because that's where my negative sign values are. So, and I meant to make this angle look the same as this angle. So if I have a reference angle of 0.63, this is also a reference angle of 0.63. But again, what we're looking for is, I need to see how far did I really travel from 0 to right there. I don't want the reference angle. I want the full angle from 0 to right there. Right? That's what we're looking for. The reference angle just helps us get there. So how would we figure out that angle? Well, I know from here to here is pi. So I need to take that distance from here to here of pi and add another 0.63 onto that to get the full angle. So I need to do pi plus 0.63 in order to get the full angle of 3.77 radians. So that would be my second solution, because again, it is within the given domain that we see right there. So that is it for part 2 of 4.5.